this is the last chapter we have for grade 8 math, our curriculum at least. So afterward, you will receive various tests. So we have final exams. Final exams are a thing in this course. Okay? Anyway, those will come in the following weeks, so you should review and prepare for them. Now this chapter is about functions. No, it's not how things work. Functions in mathematics are a type of relation. A relation is where you have two variables, and as one variable changes, the other one changes in a predictable way. In functions, the graph looks something like this, or it might have jagged changes. What can it not do, though? Well, if it's a function, you can't have the graph bend backward on itself. So for every domain value, there is only one range value. Please note that a relation can be, say, oh, for this one, if it happens to be that if you flip the axes, it's a function, then you would say here x can be a function of y. But for y to be a function of x, you must have one y value for every x value. That's the perhaps a little complicated for now. For now, let's start with polynomials. Polynomials are classified according to the number of terms they have. A monomial has one term, a binomial has two terms, a trinomial has three terms. The exponents of variables in each term must be whole numbers, and the variable cannot be in the denominator or under a radical sign. Guys, if the variable is under a radical sign, then it's not going to be a whole number. It's going to be a fraction. Like say, x, the cube root of x, that's equal to x to the 1/3 power, guys. And cannot be in the denominator. Well, 1 over x is equal to x to the power of -1. So in other words, whole numbers, that's greater than or equal to 0. Yeah. So, what is a term? Well, a term could be, say, x squared, xy, or xyz, or it could be something like 2. The 2, for example, would be a constant term. It has a degree of 0 because it's equal to 2x to the 0th power. Okay, so let's determine whether each of these expressions is a polynomial. If it is, classify it as a monomial, binomial, or trinomial. Here we have 3y plus 3 divided by y. 3 over y. If you look at the graph, it would look like that. This is not a polynomial. All polynomials will have continuous graphs. Of course, if we don't have a graph, we just look and be like, oh, it's in the denominator. The variable is in the denominator here. Therefore, this expression cannot be a polynomial. Not a polynomial. And that's based on this here. Okay, what about this one? It's 4a over 7. Now, we are supposed to write polynomials from greatest degree to smallest, and then in alphabetical order within each degree. The degree is the sum of all the exponents in a term. So for example, x, y, z because this is x to the first, y to the first, z to the first, has degree 3, or 1 plus 1 plus 1. This here would be degree 7. So this is usually, you'd see this written like this instead. 4 over 7a. So, now that we've written the a out of the fraction, we can rather clearly see that all the exponents are whole numbers that are 0 or greater. Therefore, this is a polynomial. This is specifically, there are 1, 2, 3 terms, so it's a trinomial. Now, how about these polynomials? Find the degree of each. The degree of the polynomial is equal to the degree of the highest degreed term. So the terms are term degrees are 5, because the exponent here is 5, 2, because the exponent here is 2, and 0. Because this exponent here is 0. It's 1 times x to the 0th power. Okay, so what's the degree of the polynomial? The degree is 5. Okay, now how about this one here? Well, the term degree here is 3, and this one has degree 2 because b and c each have 1. And this one is also 2, so degree is 3 for the polynomial. Let's do some exercises. Determine whether each expression is a polynomial. If it is, classify it as a monomial, binomial, or trinomial. So here we see that the exponents are p to the first power, q to the first power, and then both to the 0th power. In other words, constant term. Okay, this is a polynomial. This is specifically a 1, 2, 3 terms, so it's a trinomial. What about this? Root of 9a. Well, it's 3 times root a, or 3a, and then a is to the power of 1/2. Oh dear, that's not a polynomial. Not polynomial. Now, x squared minus 4, that is, we have 2 terms, so it's a binomial. Because all the degrees on the variables are 0 or integers greater than 0. So, natural numbers. Well, depends on who you ask, actually. Some people say that natural numbers are only for positive integers. But then, why would you bother with the term natural numbers if you can just say positive integers? Because there are naturally no tanks in this room right now. I think. I mean, unless I'm really missing something. But, yeah. Natural, isn't it? So, here, negative 8 is 1 term. It has degree 0. This is a monomial. Now, w squared plus 4w. Yeah, well, there are 2 terms here. So, it's... Does each term fit the requirements for this to be a polynomial? Yeah, they have non-negative integer degrees. So they make a binomial. And here, a squared plus b squared plus c. Well, each of these fits the definitions required to be a term of a polynomial. In total, we have a trinomial. Find the degree of each polynomial. 8y. Well, it's not marked, but this is 8y to the first power, which means that it's got degree 1. Negative h, oh, it's also degree 1. 2x to the fifth times z, oh, that's degree 5 plus 1. In other words, degree 6. This, we have a degree 3 term here and a degree 2 term here. So the highest degree is therefore 3, and so this is degree 3. Now mn to the 6th power, oh, that's degree 7. Mn to the 3rd power, oh, that's degree 1 plus 3, which is 4. And m squared, that's degree 2. Okay, so degree overall is 7. 8x squared plus 4xy minus y squared. Well, each of these has degree 2. 1 plus 1 equals 2. And 2. So degree here is 2. Notice how we went from highest degree to lowest as the usual ordering. This is how you're supposed to write your polynomials. You will find some questions don't give it to you this way just to make your life difficult. But for the most part, you're supposed to write it like this. Highest degree to lowest, and within the same degree, you go by alphabetical order. Because x comes before y, and then xy comes in the middle. If it was, say, x to the 3rd and y to the 3rd, you would have x to the 3rd, x squared y, xy squared, and y to the 3rd, in that order. Let's say we want to add polynomials. Well, we add them by combining like terms. Like terms have the same variables to the same power. For example, if you have x squared y plus x squared y, that's 2 times x squared y. But if you had, say, x squared y plus y squared, you can't simplify any further. Okay, let's do some examples and exercises. So let's say we gotta find this. Well, we gotta open up the brackets first. 8a squared minus 6a plus 1 plus a squared plus 2. You might go like, wait, why do we bother with that for additions? Yeah, it's because for subtractions, you're going to need to flip some signs. So, this is going to be 8a squared plus a squared, so 9a squared. And minus 6a, oh, there's no other a terms. There's no like terms for that. And 1 plus 2, those are like terms. They are constant terms. So you combine them to make one constant term. So, exercises. Find each sum. 2x minus 5 plus x plus 1. When we just get started, we should open up the brackets first. This is also useful if you have, say, another multiplication, like 2x minus 5 plus 4 times bracket x plus 1, for example. That would definitely be a good idea to write it all out. But honestly, like, for adding two binomials that have all their terms matching up, yeah, nah. 2x plus x is 3x, and negative 5 plus positive 1 is minus 4. So, what about 6d plus 8 minus 4d plus 1? Well, 6d minus 4d would give you 2D. And then plus 8 minus positive 1. Like, if you wanted to open the bracket, you'd have minus 4D minus 1. So plus 8 minus plus 1 gives you plus 7. And let's say we wanted to try this. 4w squared minus 6w plus 3, and then plus w squared minus 5. I'm showing you this way of doing things, like this way of grouping like terms, just so that y'all know it exists, okay? I, for one, am not an enthusiast, to put it mildly. Yeah. Okay, so anyway, 4w squared plus w squared gives you 5w squared, and then negative 6w, no change, and plus 3 minus 5, so minus 2. Now let's say we have 10x squared plus 3s minus 1 plus 4a plus 1. Are there any like terms here? Well, all the terms as variables are different. But the negative 1 and plus 1, they cancel out. So this is equal to 10x squared plus 4a plus 3s. Remember, within a degree, there's usually alphabetical order. Okay, so how about we have 2a squared plus 3ab plus negative 2ab plus b squared? Well, if you wanted to write it all out, it looks like this. 3ab minus 2ab plus b squared. So, 2a squared plus ab plus b squared. Subtracting polynomials. To subtract polynomials, you subtract like terms. It's the same as addition. You open up all the brackets, and then you group the like terms, and you add or subtract as needed. For example, here we would have equals x squared plus 3x minus 6 minus 4x squared plus 1. So x squared minus 4x squared leaves us with negative 3x squared. And then the 3x term, there's no others that have just an x for their variables, so that stays as is. Negative 6 plus 1. You get minus 5. Yeah, you just group the like terms as per addition. Now, sometimes you see this form here. This is one way to group like terms. I mean, if, say, c was equal to 10, this would just be, well, math that you learned in like what? The difference from regular vertical addition and subtraction is that you don't have to start from the right-hand side. Like, you don't have to start with the smallest digit first, because these are like terms. They don't carry over to each other, unlike with regular long addition, long subtraction. So, 7 minus 3, so positive 7 minus positive 3 gives you plus 4, and 4c minus 3c gives you just c. Okay, now what if we had, say, f squared minus 3f minus 3 minus bracket f plus 4. Well, that's minus f minus 4 when you open the bracket, which leaves you with f squared, still the same, minus 3f minus f, well, that's minus 4f. Minus 3 minus 4, well, that's minus 7. Okay. Now, how about a squared plus 4ab minus negative 2ab plus 3b squared? Well, this would leave you with a squared plus 4ab plus 2ab, because minusing a negative cancels out. And then minusing a positive is just minus 3b squared. So this leaves us with a squared plus 6ab minus 3b squared. Okay. 7g squared plus 9 minus 4g squared minus 3g plus 5. So this would leave us with, once we open up the brackets, plus 9 minus 4g squared plus 3g minus 5. Okay. So we collect the like terms. For g squared, we have 7g squared minus 4g squared. Therefore, we have 3g squared. In fact, you can even cross them off if you need to. Plus 3g. And then plus 9 minus 5, well, that leaves us with plus 4. What happens when you multiply a polynomial by a monomial? Well, you can use the distributive property, which is given algebraically as a times b plus c equals ab plus ac. In other words, when you're multiplying a bracket by something else, so multiplying a group by something, each member of that group is multiplied by that something. So the distributive property can be used to multiply a polynomial by a monomial. It can actually also be used to multiply polynomials, but we'll get to that a little later. So that would be each item of one group is multiplied by each item of the other group. So let's do some examples. Find 7 times 4x minus 8. That's 7 times 4x, which is 28x. And then minus 7 times 8. Or rather, plus 7 times negative 8. So 56. Now let's say we want to multiply by a non-constant term. Well, what's x squared times negative 2x? Oh, it's negative 2, so the coefficient stays the same because it was multiplied by 1. And then you have x squared times x, which gives you x to the third power. And then negative 3x times negative 2x, that's plus 6x squared. And then plus 4 times negative 2x, that gives you plus 4 times negative 2, so minus 8. And then the variables are just x. Find each of these products. Negative 7 times 3q plus 2. That leaves us with negative 21q. And then negative 7 times positive 2 will leave us with minus 14. Okay. 5 times d minus 2, well, that's equal to 5d minus 10. 2d to the third times y squared minus y plus 8. Well, the coefficient for the first term is going to be 2 times 1, which is 2. And then you have d to the third times y squared. And you just leave it like that. Within each term, the variables should be ordered alphabetically. Okay, like d comes before y, so there it is. Now, 2d to the third times negative y, well, that's negative 2 d to the third y. 2d to the third times plus 8, that's plus 16 d to the third. Now the next problem is 3n times m plus 4n. Remember, within each term, it should be alphabetical order of variables, so m would come before n. But 3n times m, well, the coefficient's still 3. So 3mn. And then plus 12n squared. Next is 2gh minus h times negative 2gh. Okay then, the first term is 2 times negative 2 for negative 4 for the coefficient. Gh times gh gives us g squared h squared. And then negative h times negative 2gh will leave us with plus 2 for the coefficient, and then gh squared. 5a times 2a minus 3ab plus 4b will leave us with 5a times 2a is 10a squared. 5a times negative 3ab is minus 15 for the coefficient, and then a squared b plus 5a times 4b, that's plus 20 AB. Notice that here we didn't write it in order of degrees. Why? Look, this is the order the original question spatted at us in, so yeah, we just gave it right back in that order. Now, of course, if your teacher is particularly picky about writing it in order of degrees, like they explicitly state that you should do this, as opposed to this is usually what happens, yeah, you might want to rewrite it a bit. If you have a function that is linear, it has a constant rate of change. The degree will be 0 or 1. The graphs will be straight lines. The equations can be written in the form of y equals mx plus b, where m is the slope and b is the y-intercept. You can also rearrange this to be like ax plus by plus c equals 0, or ax plus by equals c. That would still rearrange to be the same form. Nonlinear functions do not have constant rates of change and are not straight lines when you graph them. So determine whether each of these are linear or nonlinear functions. Y equals 5? Well, what does the graph look like? Oh, y is just 5. Oh, it's a flat line. Line. Linear. I wonder what the... Yeah, okay. Obviously, this is linear. So, y equals x squared plus 4. Well, what's the y value when x is equal to 0? Oh, it's 4. When x is equal to 1, or negative 1, it's 5. Oh, wait, we're already going up separate ways. It's already obviously not a straight line. Yeah. What happens when x equals 2? Oh, it's 8. Yeah, the rate of change is changing. The slope is changing. Therefore, it's not a straight line. This is nonlinear. Of course, we could also have told us that by just looking and be like, the degree of all the terms is not either 0 or 1. If the degrees are not either 0 or 1, then you got a nonlinear function on your hands. Determine whether each table represents a linear or nonlinear function. Well, here we have an increase of 1 corresponding to an increase of 2, and then an increase of 3 corresponding to an increase of 6, and an increase of 6 corresponding to an increase of 12. So for every increase of 1, you have an increase of 2. Like every increase of 1 in x is an increase of 2 in y. That means the slope is constant. This is linear. Usually, you would find all the intervals of x you are given to be the same size. This allows you to see if the changes in y are the same very easily. This question is slightly more complicated than average. Like usually you have something like this. Y is, well, who knows, but x is 0, 1, 2, 3, or 1, 2, 3, 4, or something similarly convenient. Or at the very least, the gaps are going to be the same. So here, x is plus 1 each time. Okay. But y, you have plus 2, minus 2, minus 2. Oh, hey, the slope is not the same between each of the points. Therefore, this is nonlinear. It's not a straight line. I mean, it could be straight on each section of it, but it's not a straight line. Please note that when you're given a table like this with data points, you assume that the data points are not going to be like, oh, it looks straight, but in reality, it goes all over the place in between. No, unless the function, the formula they give you clearly suggests that. Now, exercises. Determine whether each equation represents a linear or nonlinear function. Explain. Well, here, all the degrees of the terms are either 0 or 1. You can also rearrange this to 2y equals negative x plus 5, y equals negative 1/2 x plus 5 over 2. Yeah. This is linear. You could tell starting with the degrees of all the terms being either 0 or 1. And the degrees of all the variables here being either 0 or 1. Why? Because technically you could have a degree 1 term that's like x to the 1/2 power times y to the 1/2 power. Yeah. Y equals 8 over x? Well, x, the degree here is negative 1. Yeah, no. And if you think about this and what this graph would look like, as x approaches 0 from the positive side, it goes to positive infinity. And as x approaches infinity, y approaches 0. So it's already a curve. And on the negative side, it's also curved. Now this is nonlinear. Linear. Now how about y equals 2x multiplied by 3x plus 1? Well, degree 2 here is what you'll get for this function. That means this is non-linear. What about y equals 9 minus 3x? Oh, this is slope y-intercept form. The slope is negative 3 and the y-intercept is 9. So this is linear. All right, what if we want to actually graph these things? Well, we make a table of values and then we plot the points. For example, for y equals 2x cubed minus 1, if we have a graphing calculator, then wonderful. Happiness. Okay? Oh, wait a second. We're supposed to transfer this to a piece of paper. How are we going to do that? Well, then, we got to go and make ourselves a little table. X values and y values. So for x equals -1, we would have y is 2 times x cubed, in this case 2 times -1 cubed, so -2, minus 1, -3. And if x is equal to 0, y would be -1. If x is equal to 1, then y would be 1. And if x is equal to 2, then y would be 2 times 8, 16, minus 1. That gives us 15. Yeah, for our sketch purposes, this would not be very helpful, right? Because we would only have 3 points. Like we would mark them off and then try to sketch a curve through them. Well, guess what curve you would sketch with these 3 points? Bam, you would sketch a straight line if you weren't careful. So, what could we do besides these points? Well, we can add some in-betweens. Like say, -1/2 and +1/2. Well, for -1/2, 2 times -1/8 minus 1, 2 times -1/8, that's -1/4 minus 1. So that's -1 1/4. Now +1/2, 2 times 1/2 to the third, 2 times 1/8, that's 1/4, minus 1, so -3/4. Haha! Suddenly, we would have points that better showed us roughly what this would look like, and then we could sketch. Okay? Now, usually you see these tables written in order from least to largest, but in practice, when you're actually making these, if you aren't experienced enough to recognize the signs right away, such as, hey, this is x to the third. What that tells me is that if I have the graph axes having the same scale, this is going to be a really narrow and tall graph. Oh, and it's 2 times x to the third. Oh, it's going to be even narrower and taller. If you had a small fraction times x to the third or x to the fifth or something, like anything bigger than x squared, any degree bigger than x squared, yeah, if you have a really small fraction like 0.01 times x to the third, sure, you're going to end up with a rather wide graph on the limits of whatever graphing paper size or graph size you're going to choose. But otherwise, like x cubed or 2x cubed or 3x cubed, whatever, or x to the fifth, heaven forbid x to the seventh, yeah, you're going to need some really close together points to actually get a decent graph near 0. Okay, let's graph this. Y equals 0.5x squared plus 2. Well, you would have x and you would have y. It's x squared. And it's 0.5 times x squared. So the horizontal, you're going to have a reasonable amount of space before you start going up to really big numbers, which means that you can go with, say, -4, probably. Yeah. -4 looks pretty reasonable, because plus minus 4 you're going to have 0.5 times 16, so that's 8, plus 2, oh, that's 10. Okay, perfectly reasonable. For x squared, if you don't have another plus however much x term in there, this is going to be symmetrical around x equals 0, which means you could put plus minus 4 if you want. Okay? If you do have a x term, or any other term besides the x squared or x to the fourth, so the even degree terms, and the constant term, which has a degree of 0, therefore is also an even degree term. If you have any odd degree terms, you cannot do this. It's not going to be symmetric around x equals 0. So plus minus 4 is half of 16. 8 plus 2, that's 10. Plus minus 3, 0.5 times 9. So 4.5 plus 2 is 6.5 plus minus 2, 0.5 times 4 gives us 2. And then 2 plus 2 is 4. And plus minus 1, 0.5 times 1 plus 2 is 2.5. And then there's 0. 0.5 times 0 is plus 2 is then 2. And then we would plot these points. Like say 0, 2. And then plus minus 1 and 2.5. Plus minus 2 and 4. And we would proceed to try to sketch a curve through these points. If you had to, say, transfer this from graphing calculator to graph paper, or if you had to draw this from scratch on graph paper, you should end up with a curve that looks like this for anything that's x to the second power. It's called a parabola. It can also open downward, and whether it's wide or narrow may vary. If it opens downward, then it's negative something times x squared. Now for this next example, we have 0.1 times x cubed plus 1. 0.1 times x cubed, huh? Well, that means we can actually do a reasonably wide spread for x. So we might not have to do any fractions for x. Actually, we don't have to. Okay, so x equals negative 4. What happens? Oh, negative 4 cubed is negative 16 times 4, or 16 times negative 4, which is negative 64, times 0.1. Oh, that's negative 6.4, plus 1, that's negative 5.4. Negative 3 cubed is negative 3 times 9, which gives us negative 27, times 0.1, that's 2.7, negative, plus 1, leaves us with negative 1.7. So once you have these points, you plot them on your graph paper or your grid, and then you proceed to draw a curve through the points. Like this, and then like that. Okay, so that is how you graph functions. Of course, the alternative is graphing calculator or computer. Okay. So that's it for this chapter. It's also it for grade 8 course, for our grade 8 course. And, well, you should study, review, and do your homework, and be ready for the final exams. So, see you in another course.